Okay, number 17 is the industrial accident problem. A barge carrying 580 tons of liquid chlorine was dumped, and the question is, what's the volume of this cloud of chlorine? Then we're given some dimensions and told to figure out how long this cloud would be. Sort of like how big of an area is that cloud going to cover. So the first thing we have to do, and this is why I included all these conversions, is that we don't have any chemistry for tons. We need to turn this into something we can work with. So we need to turn 580 tons of chlorine into grams of chlorine. And these picket fences, which are probably very familiar to some people, but you can also see on the online answer key, I just put in the mathematical symbols for it. But these are ways called factor label of setting up long conversions such as this one. So 580 tons, and I gave you a conversion factor that said there were 2,000 pounds for every 1 ton. And a conversion factor that said every 1 kilogram is made up of 2.2 pounds. And you all know that 1,000 grams for every 1 kilogram. So one of the ways to check one of these conversions is to see, do my units cancel? I need grams, because with grams I can find moles. So tons is canceling, pounds is canceling, kilograms is canceling. I'm left with grams. This is set up right. That you multiply across the top, so it's 580 times 2,000 divided by 1 times 1 divided by 2.2 times 1,000 divided by 1, and this whole thing equals 5.27 times 10 to the 8th grams. And that's grams of Cl2. Okay, now I can do something, because moles of Cl2 is going to equal mass divided by the molar mass. So that's going to be 5.27 times 10 to the 8th grams divided by the molar mass of chlorine, which is 70.9 grams per mole. So this tells me that I have 7.44 times 10 to the 6th moles of Cl2. Well, I need to know its volume. And I have enough information to use the ideal gas law. PV equals nRT, or V equals nRT divided by P. And it was given to us in the problem. We just figured out how many moles we had. 7.44 times 10 to the 6. It was given to us in the problem that the pressure was 750. And that means for R we want to use 62.4. And the temperature was 18, which turns out to be 291 Kelvin. So my volume is 1.80 times 10 to the 8th liters. Quite a large volume. And that's the first answer. Now, in part B, in the second part, we're trying to find the we're trying to find the length of the cloud if we're told the width and the height. So, if we imagine this cloud, and this is not to scale, but if we imagine it as a cube shape, and we know its height, that was given to us as 40 feet. Let me double check. Yeah, 60 feet. And we know its width as half a mile, or since a mile is 5,280 feet, divided by 2, that'll give us the feet for the width. So, we just need to find out what's the length. What is this distance here? Because this times this times this has to equal this volume. But we have a little problem again, because this is in liters and these are all in feet. So we have to do a conversion. Now, the easiest thing to remember is that 1 liter is 1,000 cubic centimeters. Right? 1 liter is described by a cube, which is 10 centimeters on each side. 10 times 10 times 10 is 1,000. So, one side of this cube is 10 centimeters. There is a conversion factor to turn centimeters into inches. Is that for every 1 inch, it is 2.54 centimeters. And even though this looks like a measurement or an estimate, it is actually defined as that. Precisely, exactly. No wiggling around. Every centimeter, or every inch, has exactly 2.54 centimeters in it. And we also know that every foot has 12 inches in it. So if I do this, if I make this conversion, I am telling you how many feet is one side of that cube, which is a liter. If I cube this whole thing, I'm telling you how many cubic feet are in 1 liter. And this turns out to be that there are 3.53 times 10 to the minus 3 cubic feet per liter. Well, my volume was 1.80 times 10 to the 8th liters. If I multiply this by 3.53 times 10 to the minus 3rd cubic feet per liter, I end up with 6.36 times 10 to the 6th cubic feet. This is the same volume as that, just in cubic feet instead. So, since the volume, 6.36 times 10 to the 6 cubic feet, equals the height, 60 feet, times the width, 5280 divided by 2 feet, times the length, the thing I'm looking for. That means that length when I do the algebra is 40.1 feet. So this box, like I said, it's not to scale, but this cloud of chlorine gas is 60 feet tall, so it's as tall as a 6-story building. It's half a mile wide, and it is 40 feet long. and it is a death trap for anybody who goes inside it.